right, let's take a look at another graph problem. Message route. So what's going on here? We have n computers and m connections, and we need to find out if Libby can send a message to Maja, and what is the minimum number of computers, and actually we need to print out the path, not just the number. So this is actually basically the same problem as Labyrinth, right? We're given a starting and an ending position, and we need to actually print out the path between them. Except this is on an arbitrary graph instead of on a grid, which actually makes it, I think, a bit easier. We don't need to think so much about directions, right? We're given the neighbors directly, we're given the start and the end directly, we don't need to find them in the grid. So it's more abstract, but actually simpler. Yeah, so if it's impossible, we print impossible. If it is possible, then we print the number of edges, and then we actually have to print the path. And so it really is basically the same solution as for Labyrinth. We do a BFS, we keep track of the parents, and then we use the parents to walk the path backwards once we hit the end, once we find the target. So let's do it. And we'll do this one in Python. So we're given n and m. So this will be the list of neighbors for each vertex. Okay, they're probably given 1 index, but we want them 0 indexed. And C++ it's push back, but in Python it's append. Cool. So we'll use the queue data structure, which is built in to the collections module. Check of scene and parent in this sort of frontier of things to explore. So if we're done, I need to print out the path. Let me get everything else working first, and then I'll write the path printing code. If we can't find it, then we print out impossible. Right, if we do find it, then we'll exit, so we won't ever get here. And so the basic Bfs code is very simple, right? For everything we could move to, if we haven't been to it yet, then we can get to it from X and add it to the queue. You might worry that there's like some shorter path to it, but the point of BFS is that it traverses everything by how far it is from the start. So the first time we see something will be the shortest path to it. Yeah. Okay, we're walking the path from the end to the start, but we want the path from start to end, so reverse it. We're supposed to print it out space separated on one line, so that's what this will do. Here it's a list, here it's a string. It's sloppy really to change it from a list to a string. I'll just do it like that. should be fine. Message route. Oh. It's fine. You can only join together lists of strings, apparently. Let me just fix this up. Unindexed. So we can go from 1 to 4, and then from 4 to 5. These edges are bidirectional, which they did not really make clear, but obviously it's true because there's only a path from 5 to 4 in this input. We're not supposed to print out done 3, 1, 4, 5. Cool. Wrong answer. Okay, so the paths that we're printing out are too long. I see. That's because we're adding. We should also not do this if it's already in the queue but it hasn't been processed yet. So we need to set scene not just when it comes out of the queue, but when we first add it. That should fix the problem. Apparently not, though. I see. Okay, being a little bit sloppy. Right, I had this like if scene continue, but obviously everything is scene now. So I'm being a little careless about what I mean by scene. It should really be false. Not that it matters. None is considered false by Python. So the idea is that scene means that you're in the queue. So initially we should have the scene of 0 is true. Okay. And so the problem that we had was that we would sort of rewrite the parent with a worse option, even though it was already in the queue. So we, once we've added it to the queue, we don't want to add it again. So that's why we need to set scene equals true here. Okay, so that worked. So yeah, the sort of core code of the BFS is very simple. The hardest part really is printing out the path. Right. So we just walk backwards, in the parents until we get to this, from the end back to the start. Sort of, I don't know, leaving these breadcrumbs as we go. Right, where did I come from? And because we're going from the end to the start, we need to reverse the path before we print it out. X plus 1 because we want to print it out 1 index, but we're working 0 indexed. Same reason why we have these minus 1s. Keep track of the neighbors for every vertex. And we have this scene in parent, and we had this one problem where, well, I guess two problems. One where we had sort of the wrong idea about what scene should be because we needed it to become true immediately. And in this other one, we were sort of not very clear in our minds about what scene was supposed to mean. And so we were checking like if already scene continue, but that was always true because we were marking it scene there. So anyway, just important to be clear about what things mean. But that's the problem. Straightforward BFS.